And we are Team 10, and our project is siheung Smart Resilience Plan. And our final project is divided in three parts. The first one is Smart City Solution Design, and the second part is Implementation Plan, and the third Expected Impact and Expansion Plan. And for our first part, our project is the Resilient Urban Intelligence System, or you can call it RUIS. RUIS is more than just a smart system. It's our plan to solve Xiheng's biggest problem by merging the city's daily efficiency with its ability to handle disasters. Right now, the city is often reacting to crisis. RUIS shifts us to a predictive, human-centered model, a smarter, safer future. And our design is not genetic. It's a direct response to the issue we found in Xiheng's current palace. We identified three main gaps. The first one is data silos. City departments and agencies do not share data easily. Our fix is the unified data model, which is UDM. And the second is communication fragility. Lower coverage is limited, creating communication backlogs during emergencies. Our solution is the decentralized mesh network. And the third one is low participation. Many residents, especially the elderly, get let off. Our fix is digital inclusion hubs. We built RUIS to solve these specific problems. And we have the RUIS core idea, the dual mandate. The system works on platform, but in two modes. In efficiency mode, it handles daily operations, optimizing traffic, checking utility line, and monitoring air quality. It learns the city's normal rhythm. And when our productive engines see a risk, like a major storm, the system automatically switched to resilience mode. Traffic lights instantly change to clear evacuation routes, and public sign shows shelter location. This is no manual delay. And for our pillar one, predictive EWS and UDM, our EWS moves from just reading sensors to proactive forecasting. First, the unified data model force all income data from City Hall KSAOS sensors to speak the same language. This is a key. And second, this clean data feeds our AI engine, which use deep learning to combine tidal, rainfall, and traffic data. This let us forecast the impact of an event hour in advance, giving people and responders very crucial lead time. The system's architecture is built to be fault tolerant. We use a three-layer approach, edge, fork, and core to keep decision faster. The biggest innovation here is the decentralized mesh network. This network is our direct answer to the lower coverage problem. It's a self-healing, low-cost backbone that ensures that even if the main power of cellular network fails, the EWS and crucial command center can still communicate. And about our key innovation, the urban digital twin. Our second key innovation is the digital twin. This is a live virtual copy of Siheung constantly update with real data. We use it for powerful stress testing. We can instantly simulate extreme rainfall to optimize evacuation route or test shelter placement. It is also the perfect risk-free training platform for the text plus community. And next is our pillar two, inclusive community resilience. We technology must serve everyone. We specifically address the digital divide experienced in area like Teadong. We use a multi-format alert system sending information via SMS, PA speaker, and digital signs, not just apps. We also use setting up digital inclusion hubs, which are physical center where people can get trained and register for assistance. Finally, the vulnerable population registry is a secure opt-in system that lets RUIS prioritize direct contact with the elderly or non-Korean speaker residents during a crisis. And to summarize the segment, the RUIS solution is solid because of three things. First is it is integrated. Our everyday system automatically shifts into crisis mode when something happened. And second, it is robust with mesh network and the UDM. There's no single point where the whole system can fall. And third is inclusive. Everyone is designed to make sure every citizen is supported. It's not just the tech savvy or the will connect.
So now I will present the implementation plan for the RUIS. The roadmap includes the three major phases: foundation, integration, and full resilient activation. This phase approach allows the city to gradually move from the building the basic technical environment to integrating all the data and system, and finally achieving full operational resilience during emergencies. Across all phases, we ensure the three critical features. First, a unified data model which standardizes our data across all agencies. Second, a fully redundant communication backbone through the mesh network to ensure the connectivity even during network failures. And third, AI forecasting and digital twin simulation capability which help the city predict and manage the risk proactively. Each phase also must include the defined milestone to measure the readiness and stability before moving forward. These checkpoints help reduce operational and technical risk throughout the process. And by the end of the implementation, we expect the city to achieve some outcomes like fully operational technical infrastructure, improved community preparedness, and seamless switching between the daily efficiency mode and emergency resilient mode. And next slide, please. And here's our detailed milestone with step-by-step deployment strategy. In year one, we focus on building the foundation. The milestone include establishing the three-layer architecture, publishing the unified data model, and piloting the mesh network and launching the first digital inclusion hubs. And our key activities during the stage are standardizing data across the City Hall and Korea Industrial Complex Corporation, testing the mesh network reliability, training the municipal staff on data governance, and onboarding the community to use the digital inclusion hub. And the main goal of the phase one is to build a unified technical and data foundation that will support future in-system integration and predictive operation. Without this stable base, later phases cannot function effectively. And in year two, we move into the phase two, which is full system integration. Here, the CC integrates all sensors and IoT devices into the UDM and activates the disaster predictive engine. The mesh network also expands to cover the entire city, and the digital twin is tested using the real inputs, including flow simulation and evacuation drills. And the key activity includes synchronizing real-time data across agency, improving AI prediction accuracy, conducting evacuation simulation, and implementing the tech and community joint real model. The goal of phase two is to shift siheung from reactive crisis management to proactive risk-based forecasting and decision making. And in year three, we enter the final implementation stage, full resilient activation and continuous improvement. This includes deploying all multi-format alert system, SMS, PA system, and digital signature, and activating the vulnerable population registry. We also integrate real-time feedback loops into the digital twin and stress test the network for redundancy during crisis simulation. Key activities include optimizing evacuation routes, expanding inclusion hubs across the high-risk neighborhood, conducting citywide resilient drills, and reviewing performance through regular audits. The final goal is to conducting the citywide resilient drills and reviewing the performance through regular audits. The goal is to achieve more fully operational adaptive resilient system capable of automatic mode switching and rapid emergency response. Next slide, please. Uh, Successful implementation requires strong collaboration across all the stakeholders. The City Hall leads the data governance, enforce the UDM standards, coordinate the agency, and operates the RUIS command center. The Korea Industrial Complex Corporation provides industrial data, integrates the factory level alerting, and supports the digital twin simulation. emergency services like police, fire, or medical teams who receive the automatic alerts participate in digital twin-based reviews and provide feedback to improve the predictive models. The community groups are also very important as they operate the digital inclusion hubs to support the vulnerable population and facilitate communication with residents. And to connect all these stakeholders, we incorporate cooperation mechanisms such as the Joint Data Governance Committee, the monthly risk simulation review, the tech and community joint review, and a shared monitoring dashboard. This mechanism can ensure the corrective decision-making and smooth the implementation across the entire system. Next slide, please. And also, finally, we address the risk management and adaptation, which ensure the long-term stability of the IUIS implementation. We identify four major risks like UDM, compliance, the mesh network instability, low community adoption, and AI models uncertainty. To handle this risk, we propose contingency plans, including mandatory UDM enforcement, multi-layer communication redundancy, multi-format alerts, and continuous model validation through the digital twin. And additionally, the system is designed with the solution flexibility, including modular architecture, adaptive routing, and a community feedback loop. This feature makes the system highly adaptive and resilient, even under the unpredictable conditions. An overall risk framework ensures that siheung can maintain both operational efficiency and rapid emergency responsiveness. So now it's over my part.
Okay, I'm Sapira and talking about the part expect impact and expansion plan. Here I separate like three part about expect impact, disaster, resilient, and social impact. The first one is the stronger disaster detection and response. AI forecasting predict flood, storm surges, and industrial accident with higher accuracy. Integrate IoT with a digital twin dashboard, give real-time update to emergency term, automate alert, shorten response time, reducing the MAC in high-risk zone. The second part is a protection for a vulnerable population. Multilingual icon-based alert reach elderly, migrant, and low digital access resident community. Disaster hub our evacuation support, first aid, and resource distribution. Volunteers group assist mobility impaired and isolate senior during emergency. The third part is about reduce economic and infrastructure damage, prevent industrial shutdown and minimize disruption for local business. Lower city expenditure on post-disaster repair and compensation. Improve long-term asset protection and residential and industrial areas. Next slide. This is I'm talking about expect impact and expansion plan that talk about expansion plan, domestic expansion plans. I also separate three part. The first part is about target capacity for replications, city facing similar industrial climate, social vulnerability, and sun industrial accident, migrant community, Vasan, coastal floating factory, Gansan, aging industrial infrastructure, protect port-related environmental hazard. And the second part about why this model scale easily. Digital twin and AI model can be replicated using new city dataset modular LOT package support pace installation and flexible budget. Community hub model is adaptation to different event environments. And the third part is talking about schooling mechanism. Established national knowledge sharing network led by Siheung City Hall, develop standard toolkit for other multiple create share PPP frameworks to reduce development costs across city. Okay, I finish it. Thank you.
Okay, our sharing is finished.